On GoFormative, you should see this first problem is 3 sine of theta minus 2. So a couple of things. First of all, I'm using theta instead of x. No big deal. It's just referring to the angle. So don't get thrown off by theta. I could put any variable in there. You saw that when we were solving trig equations. So just roll with it. First thing I want to do is identify all of the key pieces of information. So let's do that to start. Using that trig function, and you got plenty of room on your GoFormative that you can kind of zoom in and out and write this stuff. Above or below the graph, it doesn't matter. Let's identify our key pieces of information. So that would be the midline, the amplitude, the period, and the phase shift. So I want to identify those 4 things before we start and kind of go from there. So looking at our equation, what's the midline going to be here? Yes, good. It's an equation, so we say y equals -2. It's the k value in the in your function. Good. How about the amplitude? 3. And that is just the vertical stretch, so we just say 3. What's the default period for sine?
0 to 2 pi.
Yeah, so 2 pi is our default period. Good. Now, we have to make sure that there's no change to the period, and that only happens if we have a b value. So if there's no b value, there's no change to the period. In this case, there is a b value of 1. So we would be saying 2 pi divided by 1, which just ends up being 2 pi. So no change to the period. It's still the default. How about the phase shift? This can be a little interesting. So if there's a phase shift, it's indicated by what's happening inside the parentheses. Well, we don't see any parentheses. I'm not just going to draw parentheses because I want to. Okay? There's no parentheses, which means we don't have a phase shift. So if you don't see parentheses written around your angle, there's no phase shift. So we don't have a phase shift here, which means it just lives, it starts from 0. It doesn't start anywhere else. We don't have to move the graph around. Okay, so we've got all the key pieces of information. The one other thing I want to make sure we remember is what's happening, what's the pattern of key points on that graph. In other words, sine starts and ends with a midline point. And I'm just taking this right from 6.0, so what we talked about in class on Monday. Halfway through the cycle, we're back at the midline point. And then in between the beginning of the period and the halfway point of the period, we're going to go up to our highest point. And then in between the halfway point and the end of the period, we go down to our lowest point. Now, we know that the period of this particular graph is 2 pi. So all of this happens in a distance of 2 pi. Okay, so I've got to put all of that information on my graph before I get to 2 pi. All right, so let's start putting this together. So when we graph, there's a few things. Yeah, we can still see that. A few things I want to make sure I get on my graph before I do anything else. The first is the midline. So I'm going to start by graphing my midline. Now this time my midline is at -2. So I'm going to graph just a horizontal dashed line at y equals -2. Let me make that a little bit. Can you guys see that purple okay? Okay. It's a little light on my screen. That's why I was wondering. So that is our midline. Okay, that means that we took the the x-axis and essentially just moved it down 2 units. So any midline points that we would have had on the x-axis are now going to be on -2. The second thing I like to do, and I just do this with sine and cosine. The rest of the graphs, it doesn't really make sense to do. And I've just started kind of showing my students this because they always come in doing this if they get help from some other teacher. So I thought, well, we'll throw it in here. You know that the amplitude is going to give you how much above or below that midline you need to go. So it's sometimes helpful if you sort of get a box on your graph that shows you where that function is going to live. So I know that I'm not going to go any higher than 3 units above my midline. So that's going to be at 1. I'm just going to graph sort of just a little horizontal line there. It's not actually part of my graph. It's just a guideline. And then I'm going to go 3 units below and graph that as well. So what I end up knowing is that this function, my sine function, is not going to go any higher than 1 or any lower than -5 on the y-axis. That's all I'm doing. You do not have to graph this little box here, but you can. All right, then comes the fun part, the actual graphing part. When I'm doing this on GoFormative, I use the little circle tool to plot points and just make the thickness of the marker bigger, and it's just really easy to plot your points then. Just a little hack. I'm going to not do that up here because I don't really have, actually I could just increase the diameter of my pen. All right, so we know that sine begins and ends with a midline. So I'm going to begin with a midline point at 0 for y, and I'm going to end 2 pi units later with a midline point. So I have the beginning and end of the period. Now, just visualize where the halfway point is between those two. Now, you could also calculate it exactly, but typically you're going to be able to sort of visualize. Visualize halfway through the period, and we're at pi. It's another midline point. From there, I know that the beginning of the period, from beginning to middle, I go up to my highest point, halfway between the beginning and the middle of the period. So that's going to put me up here on my little guideline, right? That's halfway between the beginning and middle of the period. And then halfway between the middle and end of the period, I'm going to be at my lowest point. And that's why I put that little guideline there, just to indicate where that lowest point is going to be. So we end up with 5 key points for our graph that look like this. Anytime I give you a coordinate plane, I want you to fill it up. So we're not just going to leave the right side of this coordinate plane with a pretty sine function on it. We want to get the whole plane filled up. So I've got to remember a couple of things. This is a pattern of points that I just created. That pattern repeats over time, over and over and over and over and over again. So if you can repeat the pattern, you can get the next cycle. Second thing I want you to remember is that every start to a period also is the end to another period. So where this point right here is the beginning of this period, it is also the end of the period that came before it. So if I think about it like that, if that's the end, the beginning had to happen 2 pi units before. So that puts me at -2 pi. And I know the beginning and the end start the same way. Now I've got the kind of rough beginning and end sketched out. Now I can finish that pattern. Halfway between those 2 points, I'll be at a midline point. Halfway between the beginning and the middle of the period, I'm up at my highest. And halfway between the middle and the end of the period, I'm down at my lowest. I have all the points I need. I have filled up that coordinate plane. Now I just need to sketch the graph. When you sketch your graph, and I know this can be a little difficult with GoFormative, try to make sure you're making these look like curves and not pointy. So they shouldn't look like absolute value graphs. Okay, they should be nice curved functions. Let's talk about secant. So the first thing I'm going to do, just like we did on the previous one, I'm going to identify all of that missing, or not missing, but key information. So let's identify, I'll do this a little more streamlined. I'll try this time. Midline. What's the midline? Good. It's y equals -1. It's an equation. We write it as y equals -1. How about the amplitude? Now, don't say none, because there's always some kind of amplitude, right? It's just 1, yeah. A is 1 in this case, so our amplitude is 1. That just means we're going to go 1 up and 1 down from our midline. Next, we usually get the period. Okay, our default period is 2 pi. Absolutely. What's B? 4. So we have to divide 2 pi by B. Okay, that's how we figure out how did the period for this particular function change. So 2 pi over 4, we can simplify to just pi over 2. So normally what takes 2 pi units to happen is going to happen in a much smaller amount of time. Essentially, when we see that 4 as our B value, it's saying there's going to be 4 complete cycles in what a normal period is. So it takes each one pi over 2 units to happen. And then lastly, we have our phase shift. What do you think? None. Good. Now, when I think about the key information for my secant graph, I compare it to my cosine graph. So watch what I do here. I'm going to think cosine. Okay, so how does cosine start and end? So think about your cosine graph. And if you need to look back at 6, 0 to figure that out, how does cosine start and end? Good. So we're going to start at our highest point and end at the highest point, because however we start, that's how we end. Halfway through, what happens? Halfway through the cycle, what happens? Now I'm thinking cosine here. What do you think? Good. It's at its lowest point. And then with cosine, in between the highs and the lows, we're going to be at our midline points. Now that's cosine. The reason I think about cosine is because that's the reciprocal of secant. What happens is that we can use just cosine to help us kind of formulate what's actually happening with secant. So now secant. What this does is it allows you to just really know sine and cosine really well, and then it'll lead you to your secant and your cosecant. So it takes away the necessity of remembering 4 functions in their graphs and really only having to know 2 in order to get all 4. So what happens is we keep the high and the low the same. Okay, that just indicates how much we go above or below the amplitude. The midline points change to asymptotes. So the midline points will change to asymptotes. That is the only thing, the only difference when we're thinking our key pieces of information between cosine and secant. Now, when I go to graph it, I'm going to think in these kind of terms. So, let's see if I can get my graph back on here so we can see it. Hopefully everything, I'm going to just zoom in on the graph. We can go back up if we need to. Okay, so I know that cosine secant begins and ends at the high point, but I need to get my amplitude on there because I don't know where my high point is without having an amplitude. So we said our amplitude was at -1, right? Or not amplitude, I'm sorry, midline. Midline's at -1. So that's here. Now, as I kind of mentioned earlier, I'm not going to include the box for the amplitudes with any other graphs except for sine and cosine. It just gets messy, I think, otherwise. Okay. I know that cosine starts and ends at its highest point, and so does secant. So I'm going to begin and end a cycle of secant at its highest point. Now, it begins at 0. And let's go back up here for a minute. I just want to make sure we add something to this. All of this happens within pi over 2 units. Right? That entire cycle happens within pi over 2 units. So that's important to remember. Okay, so we go back to our graph and we say, well, we have to end the cycle of secant pi over 2 units after it began. That means it's going to end here at pi over 2 with a high point. Between those high points, halfway is going to be a low point. So halfway between 0 and pi over 2. If you need to just count lines, whatever. But halfway between 0 and pi over 2 is pi over 4. We're going to be at our lowest point. And then anytime we're between the high and the low point, we have an asymptote. So halfway between a high and a low point, we have an asymptote. I'll make that a little bit thicker. So I'm just going to put my asymptotes in there, in between any highs or lows. Now, that is one cycle of secant. I need to repeat it. So there's lots of ways that you can repeat this pattern, but we know that it's kind of like taking copy and paste, okay? So put what you can on there. Look, I know my asymptotes, they are, if I look at these big spaces, they are 1, 2 units apart. Okay, so every 2 units, I'm going to have an asymptote. So let's put that on there. Okay, every 2 units, so if I go 2 units from 3 pi over 8, I get 5 pi over 8, including going backwards. 2 units from pi over 8 is negative pi over 8 if we're moving backwards. And then just keep that process up. Just keep showing where your asymptotes are every 2 units. So I put those on there first. And then I'm going to go ahead and graph the points. It alternates, right? In between the asymptotes, it alternates between a high point and a low point. So if I'm looking now going to the left, I'm at a high point. I need to go down to a low point. Now I'm at a low point. I need to go back up to a high point. I'm just alternating highs and lows. That's all I'm doing. So I've got the skeleton. Now I can sketch the graph. The graph itself, remember, is those kind of parabola-looking things. Now, the question is which direction do I draw them? So your little parabola pointing things are always going to point away from your midline. So I'm starting on the right side of the graph. That means this guy is going to point up, away from the midline. Okay, and I'm just going to fill in all of these little parabola-looking things, being careful not to go through any asymptotes. Also being careful to make sure they look curvy and not pointy, as much as I can. I know on, like I said, on Go Formative, that can be a little tricky. So your secant graph and your cosecant graph are going to be graphed in the same way. The thing you have to remember, if I just gave you this graph and told you to tell me what the equation was, one of you could look at it as a secant graph and somebody else could look at it as a cosecant graph that's been shifted left or right. Okay, they look identical, just like sine and cosine. So the process is the same. You just have to think about the beginning and end of the period a little bit differently. One more. So we got tangent next. So there's some really interesting things that happen with this graph. So let's talk about all of those key pieces of information. So starting with our midline. 0, good. And it's y equals 0, right? Because it's a line. So y equals 0. Right, because there's no k value written, it's 0. Okay, how about our amplitude? 1, good. That's your a value, it's just 1. All right, now we get to the fun part here. The period and phase shift are going to be interesting on this one. So what is the default period for a tangent? 1 pi. Good. Default for the other 4 are 2 pi. Default for tangent and cotangent are pi. So we have to take pi and divide by b. What is b? 2/3. So we're going to take pi and divide by b. Hopefully by now, seeing that complex fraction doesn't freak us out. It just means we're going to take pi and multiply it by the reciprocal of that fraction on the bottom. So pi times 3/2 gives us 3 pi over 2. That means that an entire cycle of the graph is going to take 3 pi over 2 units to actually occur. Okay, next up, we got to think about the phase shift. So we haven't had a phase shift on any ones we've graphed yet, but you played around with phase shift in 6.2 or 6.1. We take whatever's in the parentheses, set it equal to 0, and solve. So I'm going to take 2/3 theta minus pi over 3, set it equal to 0, and solve. I'm going to do this sort of horizontally because I'm running out of room. You have 2 ways of doing this. I'm going to multiply everything by 3 just to make it a little bit easier. So 2 theta equals, 2 theta minus pi equals 0. Add pi to both sides and divide by 2. So we get theta equals pi over 2. Now, remember, that tells us our phase shift, right? So if it's positive, what direction does that mean it moves? Right. So we're going to move right pi over 2 units. So that means the start of the first cycle is right pi over 2 units. Now let's think about what the tangent graph looks like. What are our key pieces of information for tangent? So tangent starts and ends With what? And again, you can go back and look at 6, 0 if you need to. We filled that in on 6, 0. Starts and ends with what?
Starts in the midline.
Midline. Good. So we start and end at a midline. We'll always start and end the same way. Halfway through, what are we going to have? So halfway between the midline and the midline, beginning and end, do you remember what it is? Asymptote. Good. And then here's the thing. The first half of the period, we're going to see it go up to its highest point. The second half of the period, we're going to see it go down to its lowest point. Now this time, all of that happens in a span of 3 pi over 2. So the entire cycle takes 3 pi over 2 units to happen. I feel like I graphed this wrong first period. I did. All right, so let's talk about this. I'm going to start with my midline. And my midline was 0, right?
Yeah.
Okay, so 0. I'm going to make that a little bit bolder so you guys can see it a little bit better. It's really bold, but that's fine. Okay, that's my midline. Now from there, tangent's a little interesting. So because of the phase shift, I can't just jump in and start graphing it. There are a couple ways I could do this. I've shown in the past where you pretend like there's no phase shift, graph one period of it, and then shift it however much you need to, and then fill in the rest of the graph. I like maybe an alternative approach where we say, okay, where is it going to begin? And let's just look at that as if it's like our new y-axis. So for instance, if I think about it moving right pi over 2 units, I kind of marked over top of my units here. This would be pi over 2 units right here. Now, I'm not going to make an entire line or an asymptote or anything. I just want to give myself an idea of where does it begin. Begins right there. So the period is going to be 3 pi over 2 units. We're going to have to take that into account. That's going to be important here in a minute. Let's talk about how we can graph this. I need a different color.
Wait, what's that?
This pi over 2 is showing us where the start of the period will be. The very first period of our function is going to begin at pi over 2. Okay, so we said that tangent begins and ends with a midline point. So this is going to be a midline point. Okay, that's the beginning of the period. That's a midline point. 3 pi over 2 units later, it'll be at the end of the period. If we take pi over 2 and we add 3 pi over 2 units to it, where are we? So think of that. That's a half pi plus 3.5 pi, or plus 1.5 pi, sorry, would be what? Half pi plus 1.5 pi is 2 pi. So we are at 2 pi. Now I can't see my markings here. Is where the period will end. So I'm just going to erase some of this so I can see what the markings are. All right. So we'll have a midline point at 2 pi. That's the beginning and end of a period. Halfway between those two, we're going to be at a asymptote. So let's draw in an asymptote.
How's that half? Because isn't it closer to...
Oh, sorry, that is not half. Yeah, I did not find the halfway point. It's going to be halfway, so it's going to be like right here. Sorry. You're right. And that's a really great point, right? I kind of started out putting it in the wrong place, but I should be able to tell by looking at it, it's not halfway between. So visually, that's all I did. I did no calculations there. I just said visually, I'm halfway between. Now, halfway between the beginning of the cycle and the asymptote, we're going to go up to our highest point, which in this case is just 1 above, right? Our amplitude was 1. So we'll be right here. And then from the middle of the period to the end of the period, we're going to be 1 below. That's not in the middle either. Try that again. It'd be, so I'm just going to count the lines. 1, 2, 3, 4, 5, 6. I need to go 3 lines as the middle. So right there. Okay, so all I did, guys, is I went like this. I said from here to here, I see 1, 2, 3, 4, 5, 6 like light lines drawn on there. Halfway between that, that's going to be 1, 2, 3 lines. So that's why I put that point there. I can do the same thing here. 1, 2, 3, 4, 5, 6. So halfway between will be 3. 1, 2, 3. So we're going to be just one line past 3 pi over 2. That'll be our low point. Okay, so we're just kind of getting the idea of what one cycle looks like. Now, we just have to copy and paste this, essentially. Now, you can't actually copy and paste, I don't think, on GoFormative. Maybe you can. But we can do it without it, the ability to copy and paste. What I'm noticing is everything on this graph is separated by 1, 2, 3 lines on the coordinate plane. So 1, 2, 3 lines. So every 3 lines, I've got something happening. So let's think of this as a pattern, again, that we have to repeat. So, or think of it as the end of a period and begin the next period the same way. So we're here at pi over 2. And the periods are separated by 1, 2, 3 big lines. So I know that the beginning of this period will be 1, 2, 3 units to the left. So or 3 big lines to the left. So all I'm doing is counting lines on the graph. That would be the beginning of another period. And then I just repeat what I just did. Between the beginning and the end, I will have an asymptote. Between, at the start of the period, I go up to my highest point. And at the end of the period, I go down to my lowest point. And I just keep repeating that, okay? I'll do one more. So, and I would normally want you to fill this up. This guy right here is the end of a period again. Remember, these are 3 big lines apart. So we're going to go 1, 2, 3 big lines to get the beginning of the period that came prior. 1, 2, 3. So that's right here. That's another midline point. That's the beginning. And then just repeat what we did. So halfway between the beginning and the end will be an asymptote. At the first half of the period, we're going to go up to our highest point. Second half of the period, we're going to go down to our lowest point. That's enough, I think. We could repeat this cycle to fill up the graph, but I want to get us at least a couple of good periods on here. Once you've got the 3 lines, or the 3 points inside the 2 asymptotes, we're going to connect them, but we want to make sure we connect them appropriately, right? It's not a linear function. It's a curve. It looks more like a cubic function. So make sure when you connect your points, that's what you're drawing. Draw arrows on the ends. All right, and then I would expect that you fill up the coordinate planes. I would expect that you continue this pattern, which you might be able to do pretty easily. It's not too difficult to fill this up. I'll just kind of fill it in, and you can try to fill it in as well. Repeat your pattern over and over and over again, but that's the idea. So, like I said, we're not going to talk about this again until after break, but I do have some that I want you to practice with, so at least you've had some experience with it. When we come back from break, we can jump back in and kind of go from there.